All right, example 1.85 from PreCalculus OpenStax. We're given a graph, there it is, and asked to sketch a graph of f inverse of x. Well, if we knew the equation for this thing, I suppose I could figure out the inverse function, the equation of the inverse function, and then graph that thing. But it doesn't give me the equation of this. That's probably not what the book had in mind. So how am I going to do it? Well, it turns out that just by having the graph of the function, and what are we calling this? F, you can figure out the graph of f inverse. And there's at least two ways to do this. One way you could do this is by just picking points on the graph f and knowing that the inverse function just switches the inputs and the outputs. So what I'm saying is the input 1 has an output of 0 on the graph of f. In other words, the point 1, 0 is on the graph of f. So therefore, the point 0, 1 should be on the graph of f inverse. F inverse should go through this point. And because f goes through the point 2, 1, f inverse should go through 1, 2. And because f goes through 4, 0, 2, f inverse should go through 2, 4, something like this. And then to figure out the shape from here, well, you can kind of take a look and be like, this appears to have an asymptote right here. It appears to get really, really close to the y-axis. So this thing in red should get really, really close to the x-axis. My graph should end up looking something like this. In fact, it does. This is exactly right. This is the graph of f inverse of x. If you're wondering what this graph is, this is the graph of a logarithmic function, which is something you'll learn about later on in this. And this is an exponential function, which again, you'll get these later on in your book. But you don't need to know any of that stuff. All you need to do is take x, y points, throw them over here, and then try your best to get the shape. You might not like the whole part about trying your best to get the shape. Or what if the graph of f doesn't go through any integer points and I don't want to have to try to ballpark things? Well, there's another way you can do this. The graph of the inverse function is always the mirror image of the graph of the function reflected about this line, which is the line y equals x. So if you don't like this idea of finding points and then trying to ballpark the shape, you can draw this diagonal line right here and then come up with the graph in red by taking this graph in black and just kind of flipping it over. And maybe that's easy for people to see visually, that if you take this thing and you kind of flip it over, pick it up, flip it over across this line, it would land right here. Really, those two things I described are equivalent. Like if you take this point and flip it over, it lands right here. You take this point and flip it over, it lands right here. Take this point and flip it over, it lands right here. It's the same thing I did when I switched the x and y outputs. It's just a more geometric way of thinking about things. So there's a couple different ways you can think about this example.